Okay, so work at this energy gained or taken away from the system. So let's take a pretty simple system right now. You are on the top of a hill and you're going to skateboard down it. And down here, someone has thrown a bunch of sand. So when you come down the hill, you're like, woo! And then we want to know, when you come out of this sandy spot, how fast are you going? Now before we would have said this is point A and this is point B. And we would have said, hey, the energy at point A becomes the energy at point B because we have a closed system, nothing's happening. But here it's not true, it's no longer closed because we're going to lose some energy to this sandy part here. So we want to say the energy at part A minus the lost energy equals the energy at point B. So we're basically, here's our line. Everything that happens before you get to point B equals point B. The lost energy, the fancy word for that, is just work. So in this case, over at point A, we have potential energy of gravity. We'll say, yeah, we're up 5 meters. Minus the work equals down here, you've got kinetic energy. So mgh minus the work lost to friction equals 1/2 mv squared. So right now we don't have enough factual information to solve this, so we will say that the force of friction caused by this is 10 newtons, and it acts over 3 meters. So mgh minus the force of the friction times the distance it goes is 1/2 mv squared. So mgh, well, we need a mass, we'll make it 50 kilograms. 50 times 9.8 times 5 minus 10 times 3 equals 1/2 times 50 times v squared. And when you solve that, you get 50 times 9.8 times 5. 9.8 meters per second.